We are going to discuss what's called solving right triangles today. So this is a concept that will allow us to use our trig functions. So again, we're going to be using that SOHCAHTOA if you need it. So it's always a good thing to write down and remind yourself of what those things mean. Okay, so let's talk about what solving a right triangle means. So this concept of solving a right triangle, so to solve a right triangle. To solve a right triangle. What that means is it means to find all unknown side lengths and angle measures. So basically, our goal here is to find everything about this triangle. Every side length, every angle measurement, and that's what it means to solve a right triangle. So I'll highlight that for you because it's important to understand what that means. And again, we're going to be doing that using our good friend SOHCAHTOA. Okay, so you can, I'm not sure what happened there. You can solve a right triangle. So you do this. So you can do this when the following information is given to you. So there's two scenarios. Scenario one, if you are given two side lengths. If you are given two side lengths, you can find the third side and you can find all three angle measurements. Now, of course, one of the angles is already going to be given to you because you know the 90-degree angle. The second scenario where you can use this is when you are given one side length and one acute angle measure. Now, the reason why I say acute angle measure is because since these are all right triangles, you'll already know one of the angles. You'll know the right angle. So they're giving you basically two angles in a sense, right? So that's what that means. All right. We're going to do an example of each of these. So you can see I have two pictures here down below. We're going to do one at a time. So let me move this guy out of the way if it will let me. So we'll move it down here. Okay. So that way we're just looking at this picture here. So here's our first example. So I will call this number one because it will connect with this number one up here. So for this, you want to make sure that you refer to example number one to do this. So here we go. Here's example number one. In example number one, they gave you two side lengths. Now, in this problem, it doesn't really matter what you find first. You kind of have a choice. But initially, I see I have a right triangle and I know two side lengths. And if you know two side lengths of a right triangle, can't you find the third side? Absolutely. So, these are things that we're going to be looking at. Now, let me back up a little bit. In order to solve a right triangle, what you're going to be doing is you're going to be finding all the side length measurements and all of the angle measurements. So one thing that I like to do is to give each of those things a variable. So I'm going to call this side length X, maybe call this angle up here Y, and this angle down here Z. You can use any three letters you want to essentially, but I'm going to use X, Y, Z. Okay, so what do we want to find first? Well, I'm going to go ahead and find x. So the first thing I'm going to do is I'm going to find x. Now remember, x in my picture, because I labeled it as such, is a side length. And if we know two side lengths, we can find the third side using our good old friend Pythagorean theorem. So I'll just put Pythag theorem. All right, so using the Pythagorean theorem, let's talk about what we have. This letter of x, is x in hypotenuse, or is it a leg? Right, it's a hypotenuse because it's opposite the 90-degree angle. So since this is our hypotenuse, I can set up my Pythagorean theorem as 6 squared, so leg squared, plus the other leg squared, 12 squared, equals x squared. All right, giving me 36 plus 144 equals x squared. Adding that together, if you don't have your calculator open, remember to open up that calculator I had mentioned to you guys to find this Desmos calculator. It's 180. So let me go back to here. 36 plus 144 is 180. So then you want to go ahead and take the square root of that. So the square root of 180, I know, let's just do one decimal place, okay? 13.4. So, all right, so here we go. We got x. So check it. I don't know, maybe I want to mark it as I found it. I found that. Let's move on to the next thing. Now, if you want to write your answer in here, you can, but you don't necessarily have to do that. So that's completely up to you if you want to do that. I'm going to erase that. All right. Now you get a choice. What do you want to find next? Let's go ahead and find y next because it's in alphabetical order, right? So we're going to go ahead with this problem. I'm going to move this guy out of the way again. There we go. There we go. And now what I'm going to do is I'm going to find y. Now y is an angle, right? And remember, one way that we can find angles if we know two sides is to use our trig ratios. So we're going to use a trig function or ratio to do this, okay? So in order to, and I'm going to use the two sides that I was originally given. So I'm going to use the 6 and the 12, which happen to be legs. So since the hypotenuse is not involved, I'm going to go ahead and use tangent. So specifically, I'm going to use trig and I'm going to use tangent. Okay, now remember, what we don't know is the angle. So when you go to set this up, it's going to be tangent of the angle. I don't know the angle and I called it y. That's going to equal the opposite side length from y. So opposite of y is 6, adjacent is 12. So it's going to be 6 over 12. Now remember, whenever you have this type of problem where you're trying to find the angle, you're going to use inverse trig. So keep that in mind. So we have y equals tangent -1. So inverse tangent of your ratio 6 over 12. If you need to review inverse trig, you can check out my video of that on my YouTube channel. So then you're going to go ahead and you're going to put this into your calculator. Okay. So you should have gotten 26.6, and that is our answer for y. Y equals 26.6. Remember, it's an angle, so it's degrees. So there you go. So this is the measure of angle C, right? So we have one more angle to find. We need to find angle Z. So it's the last angle, right? So the last thing I need to do here is I need to find the measure of angle C. So that's the next thing I'm going to do. So last but not least, I'm going to find the value of z. So last thing we have to find is angle A, sorry. And this is another angle, right? So it is an angle. And on this one, what you're going to do is you're going to use the idea. I'm going to move this so we can see it a little bit better over here, right? We're going to use the idea that what we know about the sum of the angles in a right triangle. Okay, so we know that the sum of the angles in any triangle, not just a right triangle, sorry, is going to be 180 degrees. So here we go. Let's do that. And this will be really easy to do because we know the other two angles. So we know we have angle B, which is 90 degrees. So 180 minus 90, which is always going to give you 90. And then you're going to subtract 26.6. It's rounded, so that means Z is going to be rounded as well. So you have to go on your calculator and do 180 minus 90 minus 26.6, enter, and you get 63.4. Looks right to me. And that is your value of Z. So there it is. We've found all three parts here. So we have the first thing that we did here. This was first. Then I found this. That was second. And then this was found third. Now, you could have done this part over here first and then Pythagorean theorem second, but I usually like to start with Pythagorean theorem. That way I have all the side lengths, and then all I have to deal with is the angles, okay?